Hello all, in this section we are going to learn about an application program where we can test the microcontroller programs. Keil is one such environment where we can write our program, compile our program and test our program. Keil program can be used for developing the assembly level program as well as high level program that are written using C. Now to start the Keil, you have to press the Keil icon from your desktop of the computer. Then we get a screen where we have to create a new project. So select project, click on new Microvision project, then give a name for your project and select a location where the folder has to be saved. Meanwhile, the Keil program will ask you for which microcontroller the program has to be developed for. So if you are coding for 89C51, that particular microcontroller name has to be selected and press OK button to proceed. Then in step number 5, select the project window from the view button. Now we can start writing our program. For that we need an editor screen. For getting the editor screen, you have to press File, then click on New. Then we get a screen where we can write our program. So our simple program has 4 lines. org00h, move a, immediate 035, add a, immediate 05h, en. Now we'll see how the remaining part of the programming has to proceed. After coding the program, save the program with extension .asm. Since the program is written in assembly language, the program has to be given a name and should be saved with extension .asm. So I am saving the program with name j1.asm as the name. Then press save and proceed for the step number 8. Now in the project workspace, you have to click on source group 1. Then you have to add the program file that we have written just now by selecting add files to group source 1. So we are asked to pick the program that is to be added. So I am selecting j1.asm file and I am proceeding further. Then before we are able to compile the program, we have to set the options for target. So press on target 1, that can be found on the top of the project workspace. We get another window like this. So here we can select the folder where the compile file is to be saved. So if I prefer my program should be saved elsewhere, so I can select that particular location by clicking select folder for objects button. Then ensure that create ex file checkbox is ticked. Only then we will get the ex file after compilation. Then click on OK. That can be found in the lower part of the slide. So proceed for the next step. Now this stage is set for compiling the program. For compiling the program, again we have to select our particular file from the project workspace. Then on right clicking the mouse, we get a menu screen. from where we have to select build target. That means we are proceeding to compile the program. Now after compiling the program, in the lower part of the screen, if our program is successfully compiled, it will say whether it has completed the compilation successfully. So we can see that if the compilation is successful, it will be reporting 0 errors. And in this program there are 3 warnings. Of course, the warnings can be ignored. Now after successful compilation, we will be getting a file j1.hex. Now this is the enlarged version of the output window where we get the compilation result. So 0 errors. So that means we can proceed to the next stage where we run the program. Now for running the program, we have to start a debugging section. Press on debug. We get a pull down window. Select start stop debug section from the screen. Then we have to select run. Now we can run the program. So the program result will be available in the accumulator as per the program we have written. So if I want to know what is the content in accumulator, in this prompt that is highlighted here using an arrow, I have to type the position or I have to name the register where we have to look for the result. Now in the screen, you can see that already I have ensured what is the content of R0. So it is containing 05. Next I am checking what is the result in accumulator A. So I am typing A and pressing the enter button. So I will get what is the current contents in accumulator. So our original contents were modified to 5 and 2. R0 was containing 5 and accumulator was containing A. So after the execution of the program, we get the answer 7 in the accumulator. So the 5 will be added with 2 that was there in the accumulator, and the new result 7 will be loaded back into the accumulator. So when the program comes to an end, we have the answer in accumulator as 7. So 0x07 is the hexadecimal representation. Now once we are finished with program running and testing of the result, we can stop the debugging section. So for that, we have to again press debug, then select start stop debug section. This time we are stopping the debugging section to end the testing stage. So we have successfully written the program, we have compiled the program, and we have tested it also. So the program is working. Now in the real scenario cases, after compiling the program, we get a X version of the file. So this X version of the file can be written into the microcontroller program memory, and we can proceed with the embedded system. So the process of writing the program into the microcontroller memory is otherwise known as burning the program. So for burning the program, there is another application program known as Flash Magic that can be used for burning the program, the X file of the program in the microcontroller ROM. Now there is another way for observing the result of the program. So if we have a simulator program of this kind, we can load the X file in the simulator and we can directly test what is happening at each line in the program. So in this window, we can observe what are the values contained in each of the registers and other locations too. So thank you. I hope all of you have understood. If you have any doubts, if you have any inquiries on what we have discussed so far, you can put your comment in the comment box. Thank you all.